Okay, today the next heat treatment process, that is tempering, we'll discuss about that, about tempering. Okay, in the previous class we have discussed about hardening, and in hardening we have just discussed how the hardening process is done and what is the changes imparted in the metal or in the steel, and finally the hardening process is useful for high carbon steel and not for others. Those we have discussed in the previous class. Now the next process of heat treatment is tempering. Now the tempering process is applied after the hardening process when some extra hardened steel is produced after hardening process. That is when the the imparted hardness on the steel is greater than the desirable hardness, that is more hardened steel is produced after hardening process, then we have to apply tempering to make the steel soften, or to impart the steel less hardened. Those part of hardening is not desirable, and obviously for those steel which are more hardened or um, harder than the desirable properties, then we have to apply the tempering process to make it soften. Now now the property of hardened steel, we have discussed in the previous class that there are severe amount of internal stresses produced in the hardened steel. That's why a higher amount of hardness is produced in the hardened steel. This much of extra internal stresses we have to make them out of the steel, and tempering process is used because of that, to make the extra internal stress make out of the steel. Now tempering process is consisting these three basic steps. One is heating the steel to a specific temperature below, obviously below the hardening temperature, because hardened the steel is already hardened and the hardening procedure is already done by make them make them hot by the hardening temperature. But in case of tempering we have to maintain the temperature that is below the hardening temperature of the steel. Second step is holding the steel at that temperature for a required length of time, and tempering process is longer than the hardening, because we have discussed in the previous class that after making the steel hot by some specific heat treatment process, we have to make them cool rapidly in the hardening process. But in case of tempering process we have to hold the temperature for a longer time than the hardening. And the next step is cooling it, usually in steel air. Using air for cooling the hot metal or hot steel, that will be obviously the process is slow. Now this is the basic process of tempering. And and if we want to discuss the procedure of hardening, is that uh, the tempering process is done obviously after hardening, not before hardening of the steel. After hardening we have to apply the tempering process to make the extra internal stress relieved from the steel. And The effect of this tempering process on the steel is that the reduced value of brittleness and tempering make the steel soften, and that is unavoidable for this kind of process because the cooling step is not rapid, cooling step is slow. That's why duct brittleness of the steel is reduced and the steel is softened after tempering. And almost for all the steels, all these kind of reduced value of brittleness or reduced value of hardness is occurred after tempering process. And this temperature is very much important because 212 degree Fahrenheit temperature, from this temperature the tempering begins. That means the brittleness or reduced brittleness, reduction of brittleness is started from this much of temperature, 212 Fahrenheit, 12 degree Fahrenheit temperature. And obviously you may decide some definite temperature, specific temperature, if you want to make the brittleness to some predetermined value, and for that cases the resulting hardness and strength will be predetermined and you have to calculate them previously. And the time, about the time, the holding time of temperature for second step, holding the temperature, the time is for 1 inch thick part, 1 inch thick steel, the holding time is 1 hour. And obviously if the part is, the thickness of the part is greater than 1 inch, then you have to add 1 hour for each additional inch of thickness. Sorry. Now for the third step, that is cooling of the tempering temperature, these has no effect on the hardness or the brittleness or ductility of the steel. And obviously this cooling step is done in the steel air, and this cooling step is not rapid, that is slow, as we are using air as the cooling agent. Now the next thing is the color tempering. This is the special thing when some oxides, some metal is present in the steel, and after heating it the metals have produced some oxide, colorful oxides, and those colorful oxides are coming at the surface of the heated steel. And at that point of time the heated steel was looking like a colorful metal, and that is called the color tempering. This color tempering indicates that indicates the structural changes are going to happen or happening in the steel, because at that moment of time the metals which are present in the steel will react with the air or the oxygen and make the oxides of them, and that's why the surface of the heated steel will be colorful, looking colorful. Okay, that is called color tempering. Now the next one special point is that austempering. Austempering is nothing but the tempering of austenite. About austenite we have discussed in the I think in the iron carbon phase diagram or iron carbon system. Sorry, iron carbon system, we have discussed that after I think 900, after not after, at 910 degrees Celsius we have got the form of iron that is called austenite and or gamma iron. and when the steel is of at that temperature, steel is that at that temperature, then the iron present in the steel will be at austenite form or gamma iron form. That steel, when that steel is tempered, then we have to follow the process of tempering, and tempering is process to reduce the distortion of the hardened steel. That is, in normal tempering or conventional tempering process, the distortion of the hardness of the steel is occurred after tempering. This portion of distortion or this portion of distortion of hardness may be eliminated or may be reduced by this tempering. But obviously this tempering process is done only for, can be done actually only for the austenite steel. That means the temperature must be in this range, 790 degrees Celsius to 915 degrees Celsius, because at this range of temperature the iron will be modified to the austenite iron or the gamma iron, and the steel at that moment will be austenite steel. And obviously the quenching and cooling process means the next two steps of tempering will be the same, but the step of austenizing process, this is the process by which the normal steel will be converted into the austenite steel. That means the iron present in the steel will be converted into the austenite iron or the gamma iron. And the main different is that the this one is the main different is the time period of holding the temperature. That is, the holding the workpiece at the quenching temperature for an extended period of time. This is the main difference between the conventional tempering and os tempering. And doing this os tempering, we may reduce the distortion of the hardness of the hardened steel, tempered steel, distortion of the hardness of the tempered steel, or the property of softness that is imparted into the tempered steel, that we may reduce or maybe or we may eliminate that distorted hardness property fully. That is the tempering. And I have just not discussed the quenching and cooling process because these steps are similar as the tempering process.